Here I've got the prototype character that I made previously, and I've attached a new rig to this to allow me to animate it. This is an Apex rig, and I'm going to be testing this. I am still undecided as to whether I'm going to use this rig or a standard KineFX rig. Both of these have arguments in their favor. However, I do not need to decide on that, as this is still primarily a prototype. So this is a base Apex rig. This rig will give me the main functionality for the character. I'm going to be testing this rig now, which will allow me to refine functionality in the future. This rig has a far more detailed skeleton structure than what I was using previously. This is a deformer based rig, so I'm using a couple more deformers than the basic rig. I'm going to work with deformers where possible ahead of blend shapes, as blend shapes can greatly increase the memory overhead. We can try and minimize the blend shape cost by creating a neural network model, which will give us an average of the blend shapes, but that would still be far into the future and is well beyond the scope of what I'm doing at the moment. The interface for this rig is very basic at the moment, and I do want to replace it. Currently this has a lot of in-scene controls, and these are primarily abstract controls. I'm not a huge fan of these kind of controls, and I do want to replace them, but I will work with them for now. The majority of these sliders act as general controls and apply for things like space switching. So for example with the legs, the majority of what we do will be done in IK, and to begin with I'm going to start by animating an extremely basic walk. When I perform this kind of walk, it will be easier if we do not have to hand animate the twist all the time, so by default I want to have the twist follow my leg controls, and this is the kind of functionality which I've got from most of these controls. So I will eventually want to convert this into a slider interface. However, all of that will wait for later. For the moment I'm going to set up some basic selection sets. Selection sets will make it easier for us to hide our controls. They'll also make it easier to key our rig. Initially I want to hide all of the abstract controls, so I'll select all of the abstract controls, I'll right click on one of the selected controls, and I'll create a selection set. This selection set can be renamed to abstract controls. Next I want to set up some selections for the arms, and the initial selections will be for the FK controls. Currently all my FK controls are hidden, and I'm going to unhide them so I can select them in the viewport. Another set of controls which I'll often use as FK controls instead of IK controls will be the spine. I'm not going to unhide the FK controls for the spine, but I will make a set for these now, as all of these controls are grouped together, so it is easy to do this. I'll call this selection set Spine FK. My FK joints are no longer hidden, so I can now select my joints from within the viewport. The joints which I'm going to select are the controls for the FK. For the arms, it's usually best to animate them in FK. FK will generally give you natural arcs, and the arms can be a lot easier to animate in FK because of this. IK is generally used when you're contacting with a surface or an object. Once I've selected all the FK controls for the left-hand side of the character, I'll make another selection set. I can then hide these controls. I'll then select the IK controls for this arm. In this case, I've got controls for my shoulder, my wrist, and the twist of the arm. I want to be able to hide these controls easily as well. Here I'm going to select the arms for both sides. There are a couple of joints which I've missed. I'll add these to my selection and I'll create a new selection set. I'll just delete the previous one. I'll then make the FK control set for the right hand side of the body. Currently both of my arms are using the IK controls, and I want them to be set by the FK instead, so I'll need to update my blending. So for this I'll once again be updating these with my abstract controls. In the future I may update these blending controls to follow along with the rig, as I will generally update blending more than I update space switching. There are however other alternatives for this which I want to set up first. So I've set both of the blends for the rig so that I'm using the FK arms. These values do not necessarily need to be keyed here, as I am not actually going to animate them, but I will key them just to be safe. Next I can hide my abstract controls, and that will give me my basic setup for this first test. I can now create the initial animation. Initially I will want to create a very basic walk. This walk will barely class as animation, and it will have absolutely no personality, and this will apply to all of the animations which I create initially. These animations will all be pretty horrible, and this is because I'm building a controller and I'm not yet trying to animate the character. Initially I want to calculate how the animations blend and what animations I need. We may need to create a lot of variations in order to blend the animation properly. There will also be a lot of animations that I want to retime easily. Essentially, I want to design the animation for the controller, and I don't want to be restricted by existing animations. For the animation, I'm going to split my viewport, and I'll work with a right viewport and a front viewport. Walks are the most basic and common piece of animation that you'll do. Along with bouncy balls, they're probably the most taught form of animation, but there are some details which you can look at. There are some aspects of the walk which are commonly taught, which are not strictly true, and there are some minor details which I should consider in terms of a controller. The first thing that I'll discuss is a very common misconception. The walk is usually described as a controlled fall, and this is correct, but one of the main examples of this is not always correct. To be fair, this example is often given in terms of anticipation and not specifically in terms of the walk, but it is often displayed as the starting point of a walk. And what is usually shown is that people will lean forward before they walk. This is not false, but it is not necessary for a walk, and it is not a universal thing. This is something which actually affects the personality of the walk, and you should not do it automatically, as it is not actually required. For this animation, I will not be animating any rotation of the hips, even though this will be required for final animations, but for timing it is unnecessary. So what actually is required for a walk is a little bit more subtle, and that is the positioning of the center of gravity. Essentially what needs to happen is the hips need to move outside of the line of the body. Essentially, if the hips or any part of the body above the hips passes over the line of the toe, this will give the forward momentum which is required, and this often is done by falling forward. And this is how most people learn to walk. Essentially, when you're a child, you gain your forward momentum by falling forward. The forward lean, however, is not necessary to achieve this. You can actually achieve this while leaning backwards. The majority of people will lean forward to initiate a walk, and this will be near universal in young children. The famous Frankenstein walk comes from this idea, specifically referring to the Boris Karloff version of this walk, in that Frankenstein's monster is actually an infant, and because of this he was portrayed with very limited mobility and a forward lurching movement. However, if you want somebody who's more formally trained, for example somebody from the nobility, especially in terms of the era from the late Middle Ages to the Victorian era, this can also apply to military officers. In these cases, you would not necessarily have that forward momentum, and removing that forward momentum can give a lot of the air of what the character is trying to represent. Another example for this would be people who went to finishing school, in which case the person would be trained how to walk and how to maintain an upright posture. And in these cases you wouldn't have a forward movement. Instead, the forward momentum would come from raising the heel. When you raise the heel, you'll bend the foot at the toes, and this will move your hips forward. And once your hips have passed the toes, you will have all the forward momentum you need to start walking. So in this case, you do not need any momentum from the upper part of the body. The next thing to consider is the starting position for the walk. The most common place to start a walk is the contact position. This is where the leading foot will make contact with the floor. This contact will usually be with the heel. This is one of two main poses which will often be used to start a walk cycle. In terms of animation, this is probably the easiest starting position. The main key pose after this will be the down position. This is where the front foot takes the weight of the body. This will also usually be the point at which the hips are at their lowest. This will be followed by the key pose for the passing position. This is the point at which the character is upright. At this point, the trailing leg will begin to pass the leg which has taken all of the weight. This position is our second main option for starting the animation. So generally we will loop this either on the contact position or on the passing position. This passing position will be followed by the up position. This is the highest point for the hips in most walks. This is the point at which the character's weight will start to take momentum, as this is where the center of gravity will pass in front of the foot again. In some ways this pose is similar to the starting position of a walk. So if you're starting a walk from a static pose, this may be a better place with which to start the walk. The next pose will be returning to the contact position. There is a lot of subtlety which we can add in between these poses, but for a basic animation, these are the poses which we need. And the big question which we have with something like this is which pose to start with. The thing to consider here is whether we should start with the passing position. The passing position can be a better transition for a lot of animation, especially for static poses like the idle pose, so it's often easier to calculate our transitions based off this pose. With dynamic poses though, it can be a lot easier to transition from a contact position to a dynamic position, and this is because it is easier to maintain momentum. All of this is stuff which I'm going to build up with very simple animations. A lot of times people will be tempted to go straight to motion capture for this. Instead, I'm going to work on my character with the simplest and ugliest animation which I can get, and then if I'm happy with how the controller is working, I can choose to use either hand animation or motion capture. This will also allow me to delay pinning down the visual style until I actually have a functional controller. I can now begin working on the animation. I'll select all of the controls and I'll key everything at the first frame. I am going to be animating this at 24 frames per second. I have a 2D background, so I'm used to animating at this frame rate, and it should not really matter as frames are interpolated. If necessary, I can always update this at a later stage. By default, Houdini will start at frame 1, so my next keyframes will be at frame 13. I'll also keyframe everything at frame 25. I'll then need to update these animations. The 13th frame will be my second contact, so I'll need to move the character forward. And I'll need to bring the right foot forward. I'll copy the 13th frame, and I'll use this to overwrite my 25th frame. The hips can then be repositioned, and the leading foot here will be the left foot. My FK controls for the leg are visible, and they are going to get in the way as I'm not going to use them at any point in this animation. So I'll create a couple of selection sets for these controls and I'll hide them. For this animation, I'm only going to be animating the contact and the passing positions, as that is all you really need to get the timing. I'll raise the right leg. I will also shift the hips forward. At this point, I want the weight of the body to be above the ankle and fully supported by the foot. I will rotate the ankle slightly here. This should actually be the most stable pose in the walk. If the pose for the passing position is not stable, it will generally mean that somebody is either injured or drunk. The next passing position will be on the 19th frame. As with the previous passing position, we'll be raising the hips, and for this pose we'll be raising the left foot. I'm not going to be rotating the hips here at all. You generally want some level of contrapposto, and you generally want some level of compensation for the hips. However, this is one of the main places where we will identify the type of character we have. The movement of the hips will have a big influence on the characterization, and there can be a lot of physiological influence on the way the hips move. This will give me my most basic walk. There's no contrapposto, there's no movement of the arms, there is no personality within this walk whatsoever. This walk will probably not loop well. I will need to adjust the positions of the feet. I also want to make sure that the positions of the start and end pose are slightly better, and that they blend properly. But I will want to make sure that I am getting the animation in the engine first. So now I want to be able to export this. First I'll need to extract the animation from my animate node, and to do this I'm going to use a scene invoke node. I'll set up this node by pressing the output all character shapes button. By default I'm outputting the shape. I do not want the shape here, I want the character's skeleton. So I'll need to update the key for the output, and for this character the skeleton is char.scale. With this I should now see the skeleton as the displayed output. I'm importing this rig as a BGO file, and I'm going to duplicate the file node where I'm importing the rig, as I'll need the base rig information for the export, specifically the character version of the export. I'll need to get information from this rig, and to do this I'll use an unpack folder node. I will need to unpack both the mesh and the skeleton. We can specify these with the extension, but that's not really a good idea here. When exporting the mesh it is best to be specific, and in this case the mesh is stored in char.shape. I'll then specify my skeleton. I have two skeletons in this geometry. One is for my guide geometry, and the other is for the skeleton itself. I only want the skeleton here, and I'll specify this with char.scale. So this will give us our base rig and our default skeleton. Next, we'll need to make sure that we're extracting the animation correctly. I am isolating the animation, but I'm not actually extracting it. To extract the animation, we will also need an unpack folder. Here I will want to specify the skeleton, and this skeleton will be stored as an output skeleton. I will need to specify information for my animation, and this will be done using a clip info node. This will define the animation that we are going to export. You can specify this information in the export node as well, but it is generally neater to use the clip info node. I'll give this a clip name walk. I'll then have two main possibilities for export. I'm going to start by exporting FBX. I may eventually move to GLTF, but FBX is well supported and you do know what you're going to get. So I want an FBX character output node. I will also want an FBX animation output node. My animation output will be connected directly to the clip info node. The first input of my character output node will be set by the mesh. The second will be set by the default skeleton position, and the third will be set with the animation. I can then specify the name for my file. The final name formats for the animation isn't yet decided, so for the moment I'll call this anim proxy walk. I placed the name in the wrong field. This should actually be the output name. I'll then specify the character. This will be anim char proxy, and this will be a walk animation. I should now be able to export these files, and I get no errors. This setup, however, is not particularly good, as currently this will have a lot of dead space where we are not animating the rig properly. This will not loop properly, so we'll need to update the clip info node, and here I'll specify the frames for the animation. Generally, we don't want to have every frame of the animation, as the final frame and the first frame will be repeated. So I'll skip the final frame, and this will be from frame 1 to 24. This animation will not loop properly at this point, because the first and last frames are not matched up correctly. And that's something which you need in order for this to work correctly. I will also need to check all of the curves for the animation, but I'm not going to be doing that yet. I'll set the clip range to be from 1 to 24. The source clip range will also be from 1 to 24. I can then save these to disk, and that should export the animation. In Unity, I'm going to import these files. I'll drag and drop them into the asset browser. So I've got two animations here. I've got my plain walk, and this will not allow me to preview animation by default because it doesn't have an associated mesh. I then have my character. This will allow us to preview the walk. This isn't looping correctly, but I'm not going to worry about that yet. So the animation is terrible, but we are getting an imported walk. If I go to the walk animation with no mesh and drag my character onto the preview, we should be able to preview this walk animation as well, and we can see that this animation is working. I can bring my character into the scene itself. This will of course not give good deformation and it will not animate, but the mesh is being imported correctly, although this mesh will have other issues. This mesh is at least usable as an imported mesh. So this Apex rig will support basic animation, and it will export correctly, and the animation is usable within my scene.